All in all, the telescope was huge. Built in orbit, it took multiple years and thousands of tons of rocket to get the material and manpower up there. A series of mirrors and collectors allowed it to achieve a diameter of well over 20 meters. While it was planned to be shared by the community of astronomers, the first mission had taken priority. We wanted to take an extremely detailed look at one of our closest star systems. The data was beyond our wildest imaginations. We discovered that one of the exoplanets could actually contain alien life. After extensive studying of its atmospheric spectra, we had undeniable proof of liquid water, organic compounds, and even seasonal variations in the level of carbon dioxide. There was only one way to know for certain if we could meet new civilizations. A group of 20 mad physicists had come up with a drive which could theoretically exceed the speed of light. Years of calculations led to our first test. In space, we attempted to remotely send a small probe through a warp bubble to our moon. The warp field collapsed almost immediately, and the small probe, along with about a gram of hydrogen, were immediately converted into mass energy. The images burned into 1,000 hypersensitive telescope cameras reminded us of the dangers to this day. Refinements were made, and we had gotten fairly good at warping gram-scale objects within our own system. Any object with volume and mass gathered particles floating around space, and released them as an outward-facing energy wave before exiting warp, making it very dangerous to nearby objects. However, no matter how much power we used, it seemed impossible to warp an object larger than a pebble within the solar system without the field destabilizing. Strangely enough, light by itself was able to be warped with very precise timing. The massless nature seemed to give it a very stable field. Another year of calculations and data collection led us to believe that it was our star's solar wind, which was destabilizing the warp fields. A plan was developed. We would send a probe directly to the potential life-bearing star to gather information, and get a closer look at the planet. It would warp in outside of the system, do a flyby, then warp out after 1,000 years. Microscopic packets of warp energy containing impulses of light would be sent to a station to bypass light lag. The suspense was killing everyone in the room. 100 tons of exotic materials and electronics, and being pushed by the most advanced MHD drive ever built. It would not bode well for the budget if it failed now. Just getting it into orbit required us to create a 10-kiloton rocket. It's almost time. Telemetry is nominal. The probe is crossing the heliopause. Pressure gradient is reducing to a negligible amount in 5, 4, 3, 2, 1, 0. And it's done. Warping in 5, 4, 3, 2, 1, 0. Warp completed. Data link established. A view screen was playing a grainy video of the probe's cameras. With that, the room exploded in cheering. Alcohol had been brought for the situations of a failure and a success. Alcohol, and more, was consumed. The probe, happily cruising through interstellar space, only took a minute to cross the distance. Coming out of warp, there was a massive burst of radiation and particles, as well over a ton of hydrogen gas was converted into energy. Okay, people, let's turn the camera into the system and see if the third planet actually has life on it.